equals 0. Okay, we have been using binomials, we have multiplied binomials by using the FOIL method, all right? We're going to use that information today, but right now we're going to learn how to factor trinomials, meaning they have 3 parts, right? 3 terms. And we're going to learn how to solve equations in that form as well. Our vocabulary will be a quadratic equation. Okay, so here is this quadratic, x squared plus bx plus c. And you'll remember that the binomials that we used before were a factor of the product, right? That these two things were factors of this product, okay? So keep that in mind. We're going to look at the pattern of those two binomials to help us to learn how to factor certain types of trinomials. Okay, so here we have x plus 3 times the quantity x plus 4, and we get x squared, and we FOIL it, and we get something that looks like this: x squared plus 4x plus 3x plus 3 times 4, right? And we combine our like terms, and we end up with x squared plus 7x plus 12, right? We all know how to do that. What I want you to look at is notice that the coefficient of the middle term, 7x, is the sum of the 3 and the 4, right? It's the sum of the 3 and the 4. And the last term, 12, is the product of the 3 and the 4. We're going to use that information and noticing that pattern to our advantage as we work with trinomials. Okay. And here it just shows us the same information in letters rather than in numbers. If we have x plus m times x plus p, we get x squared plus p plus m, right? And m times p. And that's going to give us x squared plus m plus p plus mp. Okay? So maybe just ignore this slide. It really is about what we talked about in numbers, the example you wrote down in the last slide. This is just the same thing in letters. So, do I have this slide twice? Well, isn't that cool? So maybe, sorry guys, we can forget that slide. Let me just say that notice that the coefficient of the middle term is, again, the sum of m and p, and the last term is the product of m and p. It's exactly what we were saying before, okay? All right. Those are 2 quick slides. And here we have it as a key concept. When you're factoring, when you're finding the factors for x squared plus bx plus c, to factor the trinomials, here are the steps. To factor the trinomials when they're in this form, right, you're going to find 2 integers. In this case, we'll call them m and p, with a sum of b and a product of c. So that's how we're going to factor. To factor trinomials, we're going to find two integers, right, that have a sum of m and p and a product of mp for the c. So this will be our b and this will be our c in x squared plus bx. That will be the key, plus c. Okay? So we're going to look for those 2 integers that do this. That's how we're going to factor trinomials. Okay, sometimes you know that c is going to be positive, right? If we have x squared plus bx, oops, what happened there? It doesn't like me to write up that high. Let me bring that down. Here we have x squared, right, plus bx plus c. Okay. We know that sometimes b is going to be positive and sometimes it's going to be negative. But in this example, in our first example, b and c are both going to be positive. And as you look, you can see that that's the case. Okay, to solve this, the first thing we're going to do is think of these two integers. We're going to try and think of two integers that are going to have a sum of 20, right? And we're going to think of two integers that have a, excuse me, not a sum of 20, a product of 20. You know that they're factors of 20, right? And that have a sum of the factors is 9, right? So in this case, we're looking for something that's going to be 20, and the sum of the factors is going to be 9. So I start thinking, and this is what you have to do. So yes, we are going to make a table, guys. So factors of 20, of course, are 1 and 20, right? What are some other, and what do 1 and 20 add up to? 21. So does this combination work for what we're looking for? We need something that has factors of 20 and a sum of 9. No, that doesn't work. So what about 2 and 10? 2 and 10 multiply to make 20, but do 2 plus 10, is there some? No. So let's try another one. How about 4 and 5? Those are other factors of 20. They multiply up and make 20. Do 4 plus 5 equal 9? Yes. So there's our answer, okay? So now we have found that our B and our C for this equation, right? So let me extend my page here a little bit. So we've made our chart, and that helped us find what we needed, right? So we know that x squared plus 9x plus 20 is equal to x, right? We're trying to find the factors. So it's going to be x plus 4 and x plus 5. Everybody see where we found those from? And that's what you're trying to do. You're going to make a chart, find the factors that you're going to put in these two places to make this work, all right? And in our problem solving, it says to use guess and check. Make a good guess. Obviously, you don't have to, once you find the right guess, you don't have to go any further. You don't even have to, if you know right away in your head 1 and 20 isn't going to work, start trying some other factors in your chart. Make the chart, guys. Don't shortcut it as we first learn this whole idea, okay? All right, here are two for you to practice. Make a chart, decide what the factors, what are we going to have? It's going to be, x plus something and x plus something. What is that going to be? All right, remember x squared plus bx plus c. Okay, good luck with those. All right, when factored or trinomial, sometimes the b is going to be negative. So here we go, x squared plus bx plus c. Sometimes the b is going to be negative, as in this case right here. We have x squared minus 8x plus 12. The same thing has to happen. We have to find an integer, or two integers, that the products are positive and the sum is going to be negative. Okay, since c is positive, wait, sorry, I'm going to highlight this. Think about this. Since c is positive and b is negative, right? C is positive and b is negative. You need to find two integers with a sum of -8 and a product of 12. Sum of -8 and a product of 12. So we're going to have to do sum. Let's do our product first. Keep it consistent. Product of 12, sum of 8. -8, all right? So what do you know about that? What we know that, how are we going to get a sum of -8 and a positive 12 for the product? Well, that means we're going to multiply probably what? Two negative numbers together, right? In order to get a positive product and a negative sum. So does -1 and -12 work? We can always start there. -1 plus -12 is -13, so that doesn't work, right? So then let's try -2 and -6, right? -2 times -6 is a positive 12, and -2 plus a -6 is -8. And I really don't have to go any further, but I can prove to you if we went -3, -4, well, that does add up to a positive 12, but that does multiply to be a positive 12, but it adds up to a -7. So here are the terms that we want, the two integers that we want. We want -2 and -6. So we'll say that x squared minus 8x plus 12 equals, parentheses, what are we going to put? X minus 2 and x minus 6. All right? Guess what? Here are a couple practice problems for you. Oh, no, actually I was going to say, and we'll talk about this in class some more, you can check your answers, of course, by going back and foiling your answer. And once you foil your answer, it should be the same as that. The other way you can do it, which is of course a lot quicker, and we'll learn how to do this in class tomorrow, is to graph it on our graphing calculators. And we'll be able to do that. If you guys want to fiddle with it tonight, you can, but I'll show you in class how to do that tomorrow. Okay, here are your two practice problems to factor this polynomial. Notice they're not necessarily in standard form. You're going to have to change them into standard form first. Okay, sometimes the c is negative. You know, in this case, we're going to have x squared plus bx minus c, all right? So c is negative, and let's see what happens when c is negative, right? We're going to have, here's our chart again, we're going to have a product of -15, right? And we're going to have a sum of 2. Okay, so product of -15 means I'm going to have a negative and a positive to make a negative answer, correct? So I'm going to have -1 and positive 15. That makes a -15. What's -1 plus 15? 14. So that's not our solution. Then let's try, what other do we have? 3 and 5. Let's make that -3 times 5. -3 times 5 is -15, and -3 plus 5 is 2. Would 3 and -5 work? Well, it certainly adds up to a or multiplies to make a -15, but it adds up to a -2. So it doesn't work. So our solution is going to be -3, 5. So x squared plus 2x minus 15 is going to be x minus 3 and x plus 5. How are we doing, guys? Is this starting to make some kind of sense? Once you do a few of these, you sort of get the hang of it, don't you? Good. Is that the one we just did? Yep. Okay, well, we'll just skip this page. Don't you like that? Okay, let's try another one. X squared minus 7x minus 18. All right. Now you notice both of these are negative. All right. So we have to have a product of of -18 and a sum of -7. All right, so here we go. 1 and Negative 18, right, would make a product of negative 18, but it adds up to negative 17, so that doesn't work. 2 and negative 9 adds up to, or multiplies to be a product of negative 18 and adds up to be what? Negative 7. And we could try 3 and negative 6. That also makes negative 18. We add those two together, you get a negative 3. And let's just, for the fun of it, look at negative 2 and 9. Makes a net product of negative 18, but you add those together and you get a positive 7. So here's our solution. You don't have to do these others, but for our example, I wanted to show you how we work through them and see the right one. Okay, so we have x squared minus 7x equals 18. Minus 18. And that equals, parentheses, what? X minus 2 and x plus 9. Okay? Does that make sense to everybody? Good. Again, we'll check these on our graphs, and we'll see how that goes in class tomorrow. Okay, here's your guided practice. Good luck with those. We'll put these up on the board tomorrow. All right. Second part of this chapter is solving equations by factoring. Okay, so a quadratic equation, here's your definition, can be written in standard form. So the definition is it can be written in standard form, which is ax squared plus bx plus c equals 0, where a does not equal 0. Okay, some equations in the form x squared plus bx plus c equals 0 can be solved by factoring and then using the zero product property, the one that we learned and talked about last time. Okay, so here we have x squared plus 6x equals 27. Well, you'll notice that it's not in standard form. So we're going to subtract 27 from both sides. And we'll get x squared plus 6x minus 27 equals 0. Now it's in standard form, right? Okay, now we're going to try and factor this. What are some factors that the product, can I just say product, is negative 27 and the sum, let's do that. P equals negative 27 and sum equals 6. So, well, is it 1 and negative 27? No, because that equals negative 26. How about, not 2, how about 3? 3 and, 3 and negative 9? That equals negative 27, and 3 plus a negative 9 equals a negative 6. That immediately tells me, okay, I want to use a negative 3 and a positive 9. That's going to equal 6, right? So I can factor this equation right here, right? This that's in standard form as x minus 3 and x plus 6. I'm going to set those equal to 0. Okay, I factored that quadratic, right? And I put it equal to 0, and now I'm going to find the roots, right? Remember we did this the other day. So x is negative minus 3 equals 0, and x plus 6 equals 0. So x is going to equal 3, and x might also equal 6. So those are our roots, and that's what these are called. They're called the roots of the quadratic. All right. Okay. Here's one for you to try, or two. Here are two for you to try. Make sure they're in standard form, factor them, and then find the roots. Shall I write that down? 1, standard form. 2, you're going to factor it, and then using the zero property, you're going to find the roots. All right. Yes, we're going to do a word problem. Of course. Who said no? Ling is designing a poster. The top of the poster is 4 inches longer than the rest of the poster is 2 inches, and the rest of the poster is 2 inches longer than the width. Okay, so here's our width, right? Our width is 2 inches, or the length is the width plus 2 plus 4 more inches, all right? So having a picture, we can think, okay, well, the area of a rectangle is what? A equals length times width, right? Okay, so we know we're going to, the one is, so A is going to equal W plus, which we know, the length times the width, right? LW. So we know the area in this problem is 616. 616. The length is W plus 2 plus 4, or W plus 6, right? Times the width, which is W. All right. So if we multiply that out, we get W squared. Do we need to do that? Let me think about that a second. Yes, we'll get W squared plus 6W, right? I'm going to rotate this around, guys, and and then we're going to, let me write this again. I'm reversing it. Equals 616. I'm going to subtract 616 from both sides. So I get 0, so I'm getting it. You see what I'm trying to do? I'm trying to get it into standard form. Minus 616. Extend our page. Thank you very much. Okay. Now I'm going to make a little chart. Try and factor it. And, ooh, this is tough, isn't it? 616. Well, I'm going to say this really is yucky numbers. So I'm just going to tell you it's going to be 28 and 22. We won't have anything really that hard to start with. So we're going to get W plus 28 and W plus 22 equals 0. So W is either going to equal negative 28. Can you have a negative number? Poof, I guess so. And W equals 22. Okay? Since you can't have a negative number in measurements, you know that W must be 22. All right, and so what does that mean? That means that the width is 22 inches. What's the length going to be? So this is 22 inches. This is going to be 22 plus 6, or 28 inches. Okay? Guess what? One of those for you guys to try. This will be a bonus point on your homework. So the height of a parallelogram is 18 centimeters less than its base. So what's a parallelogram, right? A parallelogram. These are parallel to each other. And this side are parallel. Okay? So the height is 18 centimeters less than the base. So if this is the base, the height, here, let me help you with that picture. The height will equal the base minus 18. Okay? And I'll let you look up online what the area of a parallelogram is. Do we know? Okay, good luck with it.